All right, let's talk about something called object-oriented programming, or OOP for short. Now, you can think of it as a totally different way to write code. Instead of just a long, boring list of instructions, it's more like building a world full of things that can interact with each other. We're going to see how this idea takes us from just a simple blueprint all the way to a living, breathing program. At its core, programming is all about solving problems, right? But way back when, programmers ran into this huge wall. The problem was their code just didn't think like we do. It wasn't intuitive. So they had to ask this really big question. How in the world can we make our code act more like the real world? The complex, messy, interconnected world we live in? Well, that single question, that's pretty much the entire reason OOP was even invented. So the answer they came up with was, hey, what if we just started modeling the real world right inside our code? And that's what OOP is. It's this huge shift away from just writing out step-by-step instructions. Instead, it's all about creating these little digital versions of real things, like a dog or a car or maybe a bank account, and then figuring out how they all talk to each other. And the key to this whole approach, the absolute fundamental building block, is something called an object. The best way to think of an object is like a self-contained little bubble of code. It holds all the information about itself, that's the stuff it knows, and it also has a set of abilities, that's the stuff it can do. Seriously, everything in OOP is built on these powerful little units. Okay, so where do these objects even come from? I mean, they don't just magically appear, right? Nope. You need a plan, you need a blueprint. And this brings us to one of the most important ideas in OOP, maybe the most important, understanding the difference between a class and an object. So, a class, that's the blueprint. It's super important to get this. A class is not the actual thing, it's the idea of the thing. For example, a car class wouldn't be a specific car. Instead, it would define the rules for all cars. It would say every car is going to have a color and a speed, and every car is going to know how to accelerate and brake. It's the master template, the master plan for making cars.
I love this analogy. Think of a cookie cutter. The class is the cookie cutter itself. It defines the shape, right? Like this is a star-shaped cookie. The object, then, is the actual cookie that you make with the cutter. See the difference? The cutter is the plan, the blueprint. The cookie is the real thing you can actually use or, run in your program.
And this, right here, is where it gets really powerful. The cool part is, you only need to make that blueprint once. You write one dog class, and then you can stamp out as many individual, unique dogs as you want. Each one, Fido, Lucy, Spot, is a completely separate instance, created from that single class, each with its own unique personality. So how does an object actually spring to life from its blueprint? There's a special term for this moment of creation. It's called instantiation. Let's look at how that actually happens. And that's where something called the constructor comes into play. If you're using a language like Python, you'll see this as __ init. Just think of it like the factory's assembly line. The second you say, okay, I want a new object, this special little function runs all by itself. Its entire job is to set up that new object with all its initial data. It's like giving a brand new puppy its name and its breed right at the very beginning. All right, so we've created our objects, they exist. Now what? Well, every single object, no matter what it is made of two basic parts. First, there's the stuff it knows, that's its data, and second, there's the stuff it can do, those are its actions. Let's start with what an object knows. In OOP, we call these attributes, and really, they're just variables that belong to that specific object. They hold all its data. So for our dog object, the attributes would be things like its name, its breed, its age. All of those attributes together define the object's current state, what it's like right now. And you can see that right here. We've got just one dog class, that single blueprint. But from it, we've made two totally different dog objects. We have my dog, whose name is Fido and breed is Golden Retriever. And then we have your dog, Lucy, the poodle. Same blueprint, but because their attributes are different, they are completely unique individuals. Okay, so that's what an object knows. What about what it can do? Well, these actions are called methods, and a method is really just a function that's built right into the class. It defines a behavior. So if a dog's name attribute is what it is, then a barking method is what it does. That action, that's the method. So how do we get our dog to actually do something? It's actually super simple and intuitive. You just take your object, in this case, my dog, and you use a little dot to tell it which action to perform. So we write mydog.bark.
And boom, just like that, you get a woof. The object has performed its action. And honestly, this is the real magic of OOP. You're connecting a simple line of code to a behavior you can actually understand.
So let's break that down. What just happened? We used something called dot notation. We called the bark method on the mydog object. This simple pattern, object, dot, method, is the standard way we communicate with our objects and tell them to do things.
Okay, so classes, objects, attributes, methods, that's a lot of new terms. You might be thinking, this is cool, but why bother with all of this? Why is this way of thinking so incredibly popular in pretty much all modern software? Well, let's zoom out and look at the real power of OOP.
It really boils down to one simple but genius idea, putting a kind of protective bubble around our code. And that protective bubble has a name. It's called encapsulation. It's one of the absolute cornerstones of OOP. What it means is that we bundle an object's data, its attributes, together with the only code that's allowed to change that data, its methods. Think about a bank account. You can't just reach into the bank's computer and change your balance, right? No way. You have to use the official deposit or withdraw methods. That's encapsulation, and it's what keeps our data safe and our programs from breaking. And when you put it all together, what you get is amazing. These simple, self-contained objects become like Lego bricks. They're the building blocks we use to construct massive, complex systems. It's how we're able to manage all that complexity and build the incredible software that we use every single day. For example, take a library management system. It's really just a bunch of objects working together. You've got book objects, member objects. Each one holds its own data and knows how to do things, like checking a book in or out. Or how about video games? They are all about objects. Your character is an object with attributes like health and methods like attack. A sword or a potion in your inventory. That's an item object with its own data and a use method. The whole game world is just these little self-contained units interacting. And it's the same for something as common as a store's inventory system. You'd have product objects, category objects, and they'd all be managed by a bigger inventory object that knows how to handle them. Seriously, almost everything you touch, from the apps on your phone to the websites you browse, is built on these exact ideas. It all starts with that simple concept, a blueprint, a class that defines what something is and what it can do. So that really just leaves one last question for you. Now that you know the blueprint, what would you build with objects?